Good day, YouTubers. Welcome back to Uncle Pythagoras. This is your hub of science. Remember that your existence counts the most. So let us do chemistry paper 2 from Limpopo Department of Education, September 2023. This is the paper that we are going to do. It starts from question 7. Question 7, it is from Limpopo Province, September 2023. 7.1, they say define an acid. Define. When you define what is an acid, define an acid. What is acid? Someone says acid is a proton donor, which is correct. Someone else can say the hydronium ions donation is the proton donor. It's an acid. An acid is a proton donor. In other words, hydrogen ion donor, that is an acid. 7.2. 7.2 says explain the difference between. You must give the difference between a weak acid and a dilute acid. Right, we'll start with the first one. The first one is a weak acid. A weak acid is an acid which does not dissociate completely in water to form hydronium ion. Now, what is a dilute acid? A dilute acid is an acid which is combined or mixed, you can say mixed, with a lot of water. When we have a lot of water in an acid, it is diluted. When the acid does not dissociate completely, it is called a weak acid. Now we are going for question number 7.3. Right, the question for 7.3 says, I will read the statement for you. When 500 cubic centimeter of sodium hydroxide solution is added to a 500 cubic centimeters of 0.25 mole per decameter cube, that is concentration of hydrochloric acid solution, the temperature rises and the pH of the solution changes to 2.3. The reaction between sodium hydroxide and hydrochloric acid is as follows. We have sodium hydroxide, it is in aqueous, plus hydrochloric acid, also aqueous, forming a salt, sodium chloride, also aqueous, and water in the form of liquid. Then the next question says, is the reaction between sodium hydroxide and hydrochloric acid exothermic or endothermic? Before we can answer that question, I need us to take everything from the statement. We are going to talk about hydrochloric acid first. In the hydrochloric acid, we know that the volume of that hydrochloric acid is 500 cubic centimeters. And its concentration, initially it was 0.25 mole per decameter cube. The pH of the whole thing, when they are added, the pH, let me write pH inside, in between here. The pH is 2.3. After sodium hydroxide and hydrochloric acid has been added, then it reacts and it forms a pH of 2.3. Then we come to sodium hydroxide. This is initial. Before everything happens, it was the beaker of hydrochloric acid, the volume of the sodium hydroxide is also 500 cubic centimeters. The concentration of sodium hydroxide is not known. Initial. This thing is initially. We don't know the concentration of sodium hydroxide, but we know the concentration of hydrochloric acid. We know the volume of hydrochloric acid is 500 cubic centimeter, as well as the sodium hydroxide is 500 cubic centimeters. Here, initially, rather let's leave it like this, and then we come back to read the question. 7, 3, 1 is the reaction between sodium hydroxide and hydrochloric acid exothermic or endothermic? Your answer is exothermic. Okay, let me explain a little bit more of this. When the reaction is exothermic, it means it reacts on its own without the aid of the external factors, such as heat, applying catalyst, applying the pressure, and so on. That reaction is exothermic. But when you put two reactants together, they do not react. They stay like that forever. They need an initiative so that they can go forward to react. So such reactions are endothermic. Right, to give you more clarity on this exothermic, the graph in the multiple choice, I'm just giving you this. In the multiple choice, they used to give you this. They say this is, another graph will say something like this. This is EA. EA stands for activation energy. Time in seconds. Time in seconds. In the exothermic reaction, the reactants and both the reactants, they can be poured in a container or in where they need to be reacting. They will go smoothly without them given a push to go on. Now they will give us a what? They will give us the product. Even here you get the product. But when we check, this will give us the heat. This is the off heat. And this will be in heat. So we are going to give this heat up to here, then it will go on its own to come and give us the product. So this one is endothermic. This is endothermic. It's whereby the reactants cannot react on themselves. They need the boost to get to react. Here, the reactants in the exothermic reaction, the reactants do not need any heat or anything from the external surroundings. They will react on themselves. Like when you pour sodium hydroxide and hydrochloric acid, they together can produce heat. As the statement says, the temperature increases. Right. So if I read the statement here, they say when 500 cubic centimeters of sodium hydroxide, this one, the volume is 500 cubic centimeters, and 500 cubic centimeters is added to a 500 of 0.25. The concentration of hydrochloric is 0.25 mole per decimeter cubic. The temperature rises. This is what I'm saying. The heat is given off. When you get the heat off, you must know that that reaction is exothermic. The temperature rises and the pH of the solution is 2,3. After everything has been, remember this is base, this is solid. I mean this is base, this is acid. When you combine the base and the solid, the reaction is exothermic. The heat is given off. Now, this is what I was trying to explain to you. Then the reaction is like that. Then I will take this. I believe that now you understand between the endothermic and the exothermic reaction. Now, they say, okay, we answered the question. They say, is the reaction between sodium hydroxide and hydrochloric acid exothermic or endothermic? That was simple. Now, 7.3.2. They say calculate calculate 7.3.2. Calculate the final concentration of hydronium ions. This is for 3 marks. We need to work here. Now, if you can check, we have this and that combining sodium hydroxide and hydrochloric acid combined to form the pH of 2.3. Then they need us to calculate the final concentration of hydronium ion. At the end, we will be having hydronium ion here, H. This is final. Let's say final. Now we are going to get a final here. Final scenario, we have hydrochloric acid combining with sodium hydroxide to form the final. This is final. The pH is still the same. Now we have the hydronium ion this side, H2H3O plus is required. They want us to find the concentration of the hydronium ion. Now, before we can go any further, we know that there is a formula that goes like pH is equals to minus a log. Let me write it a little bit down. pH is equals to negative log of the concentration of H3O plus. Now we are going to take that along with us. Then the pH is given as 2.3. 2.3 is equals to negative a log of the concentration of H3O plus. Now back to mathematics. You know that when the log has got no base, the base is, I can see hands, right, 10. Good matrix. The base is 10. Now you're changing this log form into exponential form, whereby you are having the base of 10, which is the concentration of hydronium ion, is equals to 10 to the power. Before I do this, let me show you that we are going to have a situation where we need to change our negative log to be a positive log. We need to change this negative log to a positive log, where we have to divide by a negative, or we multiply by another negative, we get a positive, a log of, I just put 10 here, concentration is H3O. Now that negative comes here, 2,3. You multiply everything by a negative. You multiply 2.3 by a negative, you get a negative 2.3. You multiply a negative log of the concentration of the hydronium ion by a negative, you get a positive. This is the step I wanted you to see. Now from here, we come to find that then the concentration of hydronium ion is equals to 10 to the power minus 2.3. When I punch my calculator, I find that the concentration here is H3O. When I punch my calculator, I find that the concentration is 0.005. Remember, this is in mole per dm cube. Before we go any further, this is in the final. Let's check the final, the number of moles of the final. Number of moles of the final, remember we're talking about the what? Everything, the volume is 500 and 500. So here the concentration, the number of moles equals to C times V. The concentration was given from the beginning as 0.25. No, the concentration is what we just calculated here. This is the concentration of the hydronium ion. Now we want to find the number of moles of this concentration. We are going to say it is going to be 0.005 multiplied by 1. Why am I saying 1? We are going to add the 500 cubic centimeters to a 500 cubic centimeters to make what? 1000 cubic centimeters. And 1000 cubic centimeters is going to be converted into a decimeter, which is 1 decimeter cube. That is going to be 0.005 moles. This is the number of moles in the final concentration of the hydronium ion. We have used these moles. Now we are going to calculate the next question. The next question must be 7.3.3. The next question is 7.3.3. 7.3.3. They say calculate the initial concentration of sodium hydroxide solution in 500 cubic centimeters. Right. For those of you who did not understand, let's come back. We have two beakers. This beaker is sodium hydroxide. They want to know the concentration in the initial. This is the initial part that they want. We have initially the hydrochloric acid. The hydrochloric acid, which is in the beaker of 500 cubic centimeters. Then the two reacts. When you combine the two, you form a 500 plus 500, which is 1000 cubic centimeters. They want it in 500. This is a very specific question, but it is very important that you understand what is required here. It is very important because they say before it reacts. So now, if we will go for a metric conversion. We have millimeters, centimeters, decimeter. The difference between them is 10, all of them. The difference between millimeter and centimeter is 10, between centimeter and decimeter is 10. So we are dealing with decimeters. Converting centimeters to decimeter, it is going to be, because we're given the concentration of the initial hydrochloric acid, it was 0.25 moles per dm3. So we need to change the centimeter to dm3. 1 decimeter is equals to 10 centimeters. Now we need to multiply this to the power of 3 is equals to this to the power of 3. Now 1 decimeter cube is equals to 8,000 centimeter cube. This is what we are trying to convert. Now, how many decimeter cube? How many decimeter cube are in 500 centimeter cube? Here. We cross multiply. This is ratio and proportion in the maths concept. Now, x decimeter cube is equal to, you see, this one goes with this one goes with this one. So you're going to say 1 dm cube, multiply that to 500 centimeter cube, and then you divide it by 1,000 cubic centimeters. A centimeter cancel centimeter cube. We are left with decimeter cube. That's what we want. Now, we are left with 500 divided by 1,000. 1, 1, 1, 1. 5 divided by 10 is half. What is that? 0.5 dm cube. Now we know that this is going to be a dm cube. All this I was doing it for you to see how we converted. Now we are going to the actual thing. Then before we can do anything, initially, let me take this thing off. Initially, for us to understand what we are doing, we need to find the number of moles initially. Because here we have the concentration, we have the volume. We need to find the number of moles. So the number of moles of hydrochloric acid, let me specify this, HCl. Now we are dealing with hydrochloric acid. The number of moles of this is N is equals to let's say concentration equals to number of moles times a volume. Concentration is number of moles times volume. And then number of moles equals to times V. C times V is the number of moles. Now we want to know the number of moles of the first beaker of hydrochloric acid before anything happens. Before anything happens, we have the concentration was given before anything happened is 0.25 mole per dm cube. You multiply that to the volume. The volume is given as 500 and we have calculated that 500 is the same as 0.5 dm cube. Now this dm cube is going to cancel this dm cube. We are left with moles. That's what we want. Now going to fetch our calculator, we are going to find that it is going to be a 0.125. 0.125 moles of what?